So we've got 20 degrees, we've got KNO3, and we dissolved, we said 20. 20 in 100 is the same as 40 in 200. And then it says, what kind of curve is that, or what kind of solution is this? Well, it's under the line. Here's the line, and it's under. So this is going to be an unsaturated solution. Unsaturated. And then it says, what type of solution is created if 40 grams of KCl are dumped in 50 grams of water? So again, we have a little issue because this is saying that we've got 40 grams of solute in 50 grams of water, but yet our curve is based on 100 grams of water. So we're going to say 50 goes in 100 twice, 40 goes into X, X is 80 twice. Okay? So now we're going to look for 80 grams in 100 milliliters of water at 60 degrees. And we're dealing with KCl. So let's go find the KCl curve. Here's the KCl. Let's find 60 degrees and 80 grams. So we're way up here. So we're above the line. The line is down here. So we have a lot more there. Now, if somebody had dissolved that all, heated up, cooled it back down, and so forth, then we might consider it being a supersaturated solution. But at this point, it's just saturated, and if you want to be really correct, you should write it's saturated with excess at the bottom. You could even do the math and figure out how much, but you could at least say it's saturated, and then there's excess sitting at the bottom of the container. Okay? So there's your solubility curves. Number 8, some more math here. It says, what's the mass? We've got volume, we've got the big M, which means molarity, and then I've given you the molar mass of aluminum and fluorine, so you don't have to go looking around for a periodic table. So we're looking for the mass, but yet we're going to deal with the molarity formula first, and the molarity formula deals with moles over liters. So molarity is 2.05 equals, we don't know what the moles is, but we do know that the volume of the solution is 0.519. Solve it. X comes out to 89.0. Okay? That's moles. Actually, that was your answer for grams. X comes out to 1.06. There we go. 1.06 moles. Okay. Then it says, what's the mass? So we have to convert moles to mass. So quickly, do your dimensional analysis. Moles goes on the bottom. 1 always goes with moles. On top, you're going to put the molar mass of this. So you got to add up 1 of these and 3 of these guys, because there's 3 F's in the formula. So add that all up together, and you should get a molar mass of 84.0 grams. And now, if you multiply across the top, divide through by 1, which you don't really need to do, now you'll come out with that 89.0 grams. So there's your final answer for that one, 89.0 grams. Number 9 says how much water needs to be added to a 0.25 liters of a 6 molar magnesium iodide solution. So these two things go together. That's what we're starting with. And we want to make a solution with this molarity. We just don't know how much water to add. We don't know what the volume is going to be. We don't know how much extra water to add and so forth. But we do know we're going to start with 0.25 liters of the stuff. So our formula is going to be M1V1 equals M2V2. So I know I want to start with a molarity of 6.0. That's what my original stock solution is. And I know I'm going to start with 1/4 of a liter, 0.25 liters. And I know that my new molarity is going to be 0.64. I just don't know what my new volume is going to be. But I know I want to dilute this much enough to get it to have a new molarity of 0.64. So I solve for x using basic algebra, and I'm going to come out with 2.34 liters. Okay, that's going to be my total volume. That's my new total volume. I gave you a hint. It says find the volume, which we just did, and then subtract the initial volume from it. So I'm going to subtract out how much stuff I'm adding. This is my solute that I'm going to dissolve in more water. Okay, so I'm going to subtract that out, and I end up with 2.09 liters of water should be added, just water. I've got my total solution. I know what the final volume is going to be. This is going to be my V2. and then I know, or I say to myself, I'm going to start with 0.25 of my concentrated stuff, so subtract that out, and this is how much extra water you're going to add. Number 10, percent solutions. These guys are nice and easy. You're going to deal with percent is the part equals part divided by the whole thing. So our part is 53.8 milliliters of ethanol, and the whole solution is 300.0 milliliters of solution. Divide the two, multiply by 100, and you should get 17.9%. 17.9% by volume of ethanol. Number 11, what's the mass percent, so we're doing percent by mass, of aluminum fluoride when 0.022 moles or da-da-da-da. So we're going to deal with percent, and it's by mass, so it's the part that's in grams, that's aluminum fluoride, divided by the part, or the whole solution in grams. Now the only catch is, the problem's not giving me grams of aluminum fluoride to start with, it's giving me moles. So I have to do some behind the scenes math. So 0.022 moles times 1 mole on the bottom. What's the mass for aluminum fluoride? Well, I had figured it out earlier, so let's scroll up and let's see. Right there, I knew the aluminum fluoride equaled 84 grams per mole. So I'm going to plug that in down here. 84. Then I do out my math, and I end up with about 1.96 grams. So that's how many grams I have. And that amount is dissolved in 24.2 grams of water. So now, it's a little bit trickier. I put the grams of my solute on top, and on the bottom is going to be my solute plus my solvent to give me the whole solution. So I'm going to put the 1.96 plus my 24.2. And that'll give me the total mass of my whole solution. And then I just divide through, multiply by 100, and my final answer is going to come out to 74.8%. And there's my final answer for that one. Okay. So be able to do these problems. I'm not going to give you the formulas. I expect that you can memorize. The percent you should be able to do since many years ago. You know that it's part divided by the whole. Remember the red M&Ms divided by all the M&Ms in the entire bag. The molarity you should be able to do. It's always moles divided by liters. Make sure you have moles on top, not grams. Make sure you have liters on the bottom, not milliliters or anything else. And then doing dilutions. M1V1 equals M2V2. And so those are the things you should memorize or you should know. And finally, the last question. It says, what are three colligative properties discussed in 16.3? Explain why each of these properties occurs. So the three properties are lower vapor pressure, a freezing point depression, and boiling point elevation. Now real quick, lower vapor pressure. Remember the solute particles decrease the number of solvent particles that are able to escape. This is kind of like holding the ice cream cones for the little kids standing on the desk. They're less likely to fall off because they're hanging onto those ice cream cones. So we've got fewer escape particles, there's less collision, so we have lower vapor pressure. That ties right into boiling point. Let's talk about that one next. The boiling point is going to be higher. Now you remember, hopefully, that the boiling point occurs where the vapor pressure equals the atmospheric pressure pushing down. When these two variables are equal, then it's going to boil. If this vapor pressure is lower because of this, what we just explained, like the little ice cream cones, if the vapor pressure is lower, we have to add more energy to get it up there. So we're going to add and increase the boiling point. Okay, so extra energy is needed to increase the vapor pressure high enough to match the surrounding atmospheric pressure to get it to boil. And finally, decreased freezing point. Solute particles disrupt the formation. Remember, the particles are slowing down and trying to get locked into a position where they can just sit and vibrate. The solute particles get in the way of that, so we have to take away more energy to get them to finally lock into position and freeze or solidify. Okay. So study all your notes, chapter 15 and 16, mostly chapter 16. Be able to do all of the equations, take out the review sheets that you've got, go through some practice problems, cover up the answers, do it on your own, see if you can match up and get the right answers, and you should be all set for the quiz or the test. Good luck.